Okay, so with our recursive Fibonacci program, the name of our method is fib, or Fibonacci, and it takes one integer, which is the index of the number we are looking for. So for this one, we're actually going to be looking for the 6th number in Fibonacci's sequence. And if you don't know what Fib's sequence is yet, I'll show you right now. Fibonacci's sequence starts with the number 1, and has another 1, and then 2, then 3. What it is after the first two numbers, every number that comes next in the sequence is the sum of the previous two numbers. So after 1, 1, you have 2. It's the sum of 1 and 1. Then the next number in the sequence is 3, the sum of 1 and 2. Then the next number is 5, which is the sum of 2 and 3. And then the 6th number in the sequence is 8, the sum of 5 and 3. Okay, so we know that we're looking for the 6th index, which is our 8 right here. So our answer should be 8 at the end. So we start off. Our first call on the stack is going to be at 6. So at index equals 6. So we look at it. We know 6 is not 1. As in 1 is an index 1 of the sequence. We're going not on 0 based here. We also know that it is not at 2. So instead, we do this return statement at the bottom where we do the fib of our index minus 1, which would be 6 minus 1, plus the fib of our index minus 2. Now this is because we're summing, adding up, the previous two numbers. So we're going to now do two different calls, one for 5 and one for 4, because notice we have two different method calls happening here. One where we're looking for 5, another one we're looking for 4. So we check 5. 5 is not 1, and 5 is not 2. Because in either of those cases, we return 1, because those are the first two numbers. So with them not being either of those, we return the fib of 5 minus 1, and the fib of 5 minus 2. And I'm going to go ahead and segment this off so that way we can, keep it separate. We'll do 4 at the same time. We'll just go through this at the same time as we're going through each part. 4 is neither 1 nor 2, so we get the fib of the previous two numbers, 4 minus 1 and 4 minus 2. And you'll notice, this is one of the funny things that happens when you have a recursive method with two method calls, is your program keeps getting more complex. This is one of the difficulties of recursion. But anyways, so we make this next call from the 5 stack with 4 and 3, and I draw a line to separate them. And we'll do the same thing over here with 3 and 2. We do those two numbers because that's 4 minus 1 and 4 minus 2. Let's start on a new page though, sorry. So 4, this first number we're starting with, is not 1. 4 is not 2. So instead, since it's neither of those numbers, we return the fib call of 4 minus 1 and the call plus the call of fib of 4 minus 2. Alright, so that'll be for one of them. On the 3, for one of the 3s anyway. And I'll go ahead and include this division first also. So that one's going to call 3 index of 3 and index of 2. By the way, this is getting really complicated. So, if you're feeling lost, you might check one of the other videos first. Or just start in the hardest setting here, because you want a challenge. Okay, so we'll come back to that one. Let's do this 3 and draw a line to divide them up. Alright, so we know 3 is not 1, nor is 3 2. So we'll return, and I'll just write right here because I don't have enough space, of 3 minus 1 plus the call of fib of 3 minus 2. And we know that's going to result in the calls of 2 and a call of 1, and we'll divide those by lines. So as you can see, we're getting to the bottoms to our base cases of 1 and 2. So let's go ahead and handle this next one, and we'll just have one more of these to handle, and then we'll start returning things. Well, actually, finishing the returns. So 3, same thing as the other 3. We call fib of 3 minus 1 and fib of 3 minus 2, which is going to be a call, one call to 2, one call to 1, and split them up. Okay, so here's our other call that was at this level, and you'll notice it's 2, which, though it is not equal to 1, it is equal to 2. So we actually have our very first base case. So that means we return 1. Finally, a number. Not a method call, but a number. We're returning a number here. And remember, all the other method calls rely on sums, on adding. So that's important. So our next one that we're finishing up returns a 1 also, because it's at 1. Then we have another call with 2. 2 is not 1, but 2 is 2. And so we return another 1. So you're getting the idea that at the end of this, and that is a 1. You're getting the idea that at the end of this, we're going to add up all these numbers that we've been returning. Because it's like each time that we return 1, it returns back to that function call, like here, where we return 1 from the 1 call. That means this becomes return 1, well, not just 1 plus 1, but rather, well, yes, in this case, 1 plus 1. And then that one's going to return a 2 when we call it later. But anyways, back to this one. So in the 2 call, if you didn't understand that, ignore it. But on the 2 call, 2 is 2, so we return 1. And then on the 3 call, well, that one, it's not 1 or 2, so we have to actually split it up again. But thankfully, we only have to split it up to 1 level. And I'm not even going to write the function call in this one, because who cares? You know that we're looking at 2 and 1. And so with this one, we return 1. With this one, we also return 1. So that means that that 3 call returns 2. Well, returns 1 and 1. So if we add all these up, we get 1 plus 1 plus 1 plus 1 plus 1 plus 1. Wait a minute. Why am I only getting up to 7? Oh, yeah, there's one all the way on the left. That's no, Kevin. Check the other page. It's right there. There you go. All right. So we found all 7. There it is. It's right there. I actually did find it. Okay, so 8. Now we're all the way up to 8. All right. So, and that's our answer. So, in summation, Fibonacci sequence involves adding up the previous 2 numbers, which we accomplish here by having these 2 base cases that handle the first 2 numbers, and then every other case is just simply adding together the result of everything that came before it. So each time that we're returning something, we're returning anywhere from 1 up to, well, in this case, up to 5. Because the reason for that might take a little bit to understand, but here's probably the best explanation I can give you. The return is for the recursive call of the previous number and the number before that. And when you get all the way down to the very most basic numbers, 1 and 2, they're each going to return 1. So, for instance, if you take the recursive call of fib at 3, and that's going to return the sum of fib at 2 and fib at 1. Now, the result of fib at 2 we know is 1, and the result of fib at 1 is also 1, which means that the call fib at 3 returns 1 plus 1. In other words, 2. So if you were to have the function call 4, fib at 4, that's going to return fib at 3 plus fib at 2. Well, fib at 3 we said was equal to 2, because it's equal to 1 plus 1. And fib at 2 we know is equal to 1 as well. So adding those 2 up, we get 2 plus 1, which equals 3, which is actually the 4th number in Fibonacci's sequence. We can keep going with that example. If we had fib at 5, fib at 5 involves, what is it? Yeah, fib at 5 would return the result of fib at 4 plus the result of fib at 3. Well, if you remember, the result of fib at 4 is actually equal to 3, and the result of fib at 3 is equal to 2. So you get 3 plus 2, which equals 5, which is the 5th number of the sequence. Then, when we go all the way back up to the result of fib at 6, that's going to be the return Fibonacci at 5 and Fibonacci at 4, which we know the result of fib at 5 is 5 because we just said it, and the result of fib at 4 is 3. Add those two up and you get 8, and that is what is returned. I guess that's about all I can really say on that. Yeah, recursion is a very difficult concept for some, including myself back in the day. For others, it's very easy. Do your best to understand it, and ask me questions. See you next time.